All right, welcome eighth grade. I'm going to go over your work for today and take you through some things on the class notes. So if you can go ahead and open up the class notes, you can actually just leave this video in the background and just listen as I go through some things and have you click on some various things on the class notes and afterwards. So if we start on the class notes, the first thing I have here is some of the vocab terms from last week. On the back of your board worksheet for this week, you will actually see all of these terms listed. You can get these down in your own words on your own time, but it will be important that you have these terms down. These are all things that we've already gone over. I just got them down in the notes. So we can start with electrons, which are negatively charged particles. Protons are positively charged particles. We talked about this in our first experiment with the balloons, and we charged up a balloon by rubbing it up against a shirt that added some electrons to the balloon, and because opposites attract, the balloon was, because it had an excess of electrons, was attracted to all the positive charges essentially in the wall, and it stuck to the wall. Now, when I charged up two balloons, I had one balloon hanging. You can see in orange here where I'm at. I had the balloon was negatively charged, and then the other balloon that I had was negatively charged. And when I brought them close to each other, they repelled each other. And that's sort of the basis for electricity, which is electrons moving along a path. So when electrons move, we get electricity. The other term that you'll see on there is neutrons. And I'll just add that here. Neutrons are atomic particles without a charge, okay? And they just add mass to an atom. And we're not going to get into those a lot right now. It's more of a chemistry thing. So we'll just leave it at that. So electricity, though, however, I just said, is just electrons moving along a path. And there are things that they can go through, insulators and conductors, which will make that flow of electrons very difficult or very easy. So insulators make electrons move through. The electrons move through insulating materials very slowly, and it basically stops electric current. So things like foam, plastic, wood, glass really slow down the flow of electrons to the point where they can't really keep an electric current going. And that's kind of the same thing that we saw with our various ovens and coolers that we made. The same materials that insulate against the movement of heat also insulate against the flow of electrons. The opposite of that then is conductors, which are materials through which electrons pass easily. So any kind of a metal is going to be a good conductor, and that's why we use different kinds of metals for our wires. Also some salty solutions. And the conductive ink that we worked with when we were making those circuits with the circuit scribe pens, that particular ink actually contains very small bits of metal and mixed together in a specific solution so that it can write and you can be on the paper easily. Then we kind of, as we made a lot of circuits last week, we talked about open and closed circuits. Any circuit that does not have a complete path would be an open circuit, so it won't light up. A closed circuit is all closed up on all ends. The negative connects to the positive, and you can put any sort of a load like a light or a motor or a speaker in between, and it will power up, if you will. And then we got into really the series and parallel circuits. We're going to talk a little bit more about that here in a bit. But the series and parallel circuits are two different types. A series circuit has only one path, so if that path is broken, then the circuit doesn't work. And a parallel circuit has multiple paths, and we're going to look more in depth at that here in a little bit. But before I go into that, quick review of volts, amps, and ohms, which we're going to do some more with tomorrow. We're actually skipping some things with it today because I'm not there, but we'll continue with that tomorrow. So volts is just the amount of push, and we'll kind of talk about this whole idea of the potential difference tomorrow. And it's kind of like pushing a shopping cart. The faster you push the shopping cart, the more power you put behind it. That's like higher voltage. Voltage is all about the push. The amps is, if you use that shopping cart reference, is kind of like how much is in the shopping cart. So it's the amount of electrons being pushed. And the more electrons you have passing by a point at a given time, or like kind of like putting more in a shopping cart, that's kind of a higher amperage. And then the resistance is just what's slowing those electrons down. So if we want to, again, keep with that shopping cart metaphor, The shopping cart, you're pushing the shopping cart, that's the volts. The amount of stuff you have in the shopping cart is like the amps. And then the surface on which you're pushing the shopping cart is equivalent to the resistance or the ohms. And so that is how much it slows down. So if you're on a smooth tile surface, it goes pretty fast. If you're on sand, it's going to slow down a lot. And if you're on like a rough blacktop, that's kind of in between. So if you can go to this right here website, click on the web.archive.org, then I will take you through kind of what this shows you here. And this is something that we looked at this before. And this is something I'm going to show you. You can see that this is an open circuit. And in the open circuit, you can see on this diagram, and this is a website that you guys have already looked at, that the electrons are just staying with their atom. But the second that we close that circuit, the light bulbs turn on, and you can see that the electrons are flowing. But one of the things, this is a series circuit. And as these electrons are flowing all the way around this circuit here, if I take one thing out of the circuit, that all of a sudden breaks the circuit and it doesn't work anymore. So that's one of the things. If I put this back in, it all of a sudden works again. If I take a battery out, it also doesn't work. The circuit doesn't work. But now we're going to try something different though. If we look here, if I click the forward button, and you guys can do this too, then what you'll see is, again, we have an open circuit. It's not closed with the on button, and you can see that those electrons are just still hanging out with their atoms. But as soon as we do, now all of a sudden both light bulbs light up, and you can see though that the electrons are traveling on two different paths. They can go down towards the first bulb, or they can go over to the right to go to the second bulb. The cool thing about this is if I take out one bulb, you can see that that path is closed, but the other path is still open. So that's really the difference between a parallel and a series circuit. A parallel circuit, there are multiple paths. You can see that they're going multiple paths, but I can even just close one of the paths and the other path is still open, so one of those bulbs will still stay lit. So that's, again, just the very basics of series and parallel circuits. Now if you guys go to Google Classroom, you are going to open up the current electricity, BBC current electricity sheet, and you're going to go to this BBC website, and on this BBC website it's going to take you through a series of questions about really about volts and amps and current and things like that, and you just write in your answer A, B, C, or D, or actually just A, B, or C in the answer space. You're going to skip over the lab portion of it. We'll do that tomorrow. But then what you're going to do, and this is where you may want to look over at the video to kind of see what I'm doing on this, is when you get to this portion of the assignment here, you're going to write in the electron path. And so what you do, it says you need to double click on the picture to modify these. And you can see what I have put in is a series of arrows to show where the electron path is. And you can see that this first one I called, it's a series circuit. The electrons have only one path. So what you will do then is if you just click the little line selector here and you grab an arrow, you can now put in an arrow to show the path or paths of electrons. And so when you were done putting in all those paths and labeling the circuit as series or parallel and telling the number of paths, then you can just click Save and Close, and that will be good. So when you're all done, just go ahead and click Turn In, and you will be done with your assignment. So quick review, go to the BBC page, answer the questions, and then do the circuit diagrams, and you will be done.